All right, let's try this again. This lesson is Translation Nucleic Acid to Polypeptide. Shall we review? This is from a few lessons back. What are 3 differences between DNA and RNA? What are 2 differences between transcription and DNA replication? Here is the tRNA. And please notice at the beginning there's the amino acid, and over here you can see the UCA. This is called the anticodon. It corresponds to UGU, AGU on the mRNA. They have a distinctive cloverleaf structure with the amino acid on the other side, and it carries. So if you had the mRNA being AGU, then the corresponding anticodon would be UCA, which carries serine. Looking here, we have the wobble hypothesis. So if this is the mRNA, you have UAC matching up with AUA, which codes for tyrosine. In the third position, you can see instead of a C, we have a U, which still codes for AUA, which still gives you tyrosine. So in the case of a mutation at the mRNA level, there's a corrective option. So that's a redundancy built in. So you can see when reading, we automatically and mentally autocorrect. Thus we can read and it still makes sense. So you can see I made 2 mistakes here. Some of you may not have even noticed because we're so used to autocorrecting. You don't need to have 61 different tRNAs because if UAC or UAU can pick up the same tRNA, then you can still pick up tyrosine. The process of adding an amino acid to tRNA is called amino acylation, which is charging a tRNA. Each tRNA, each amino acid has a specific enzyme for it, and the energy comes from this complex. Okay, so looking at this, we have a small ribosomal subunit, the large ribosomal subunit, the mRNA, the tRNA, and A, P, and E sites. Some basics. Generally, the ribosome carries out protein synthesis by translating the RNA into chains of amino acid, using the information tape of the mRNA to accomplish this task. The ribosome is made of 2 subunits sandwiching around the mRNA. You can look at these if you want to. There's some special binding sites. There's the A site, amino acyl site, where the tRNA comes in with its payload of amino acid. The peptidal site, where the peptide bonds are formed between the amino acids. And the exit site, where the tRNA exits after it's dropped off its amino acid. Okay, there are 3 parts to translation. One is initiation, the second is elongation, and the third is termination. So here we have the small ribosomal subunit. Not shown is the mRNA, so it would be A, U, and G, which is the start codon. And then the anticodon is UAC. Then the tRNA with the methionine comes and forms a complex. This complex then finds the mRNA, latches onto the 5' cap, and then zooms along until it reaches the start codon. At this point, then the large subunit attaches itself, which completes initiation. Next is elongation. So after initiation happens with the start codon, then you have the bases are read 3 at a time on the mRNA. So this is called the reading frame. There's 4 steps here. So once again, you have the initiator tRNA binds to the P site. Then you have another tRNA coming in and attaching the amino acids together. GTP is used for this. Methionine is cleaved from the tRNA, and this bond is catalyzed by peptidyl transferase. You can see more clearly in the picture. All right, so this is complex is done because initiation is done. We have this starter tRNA in place. The second amino acid comes in to the A site. Then the enzyme peptidyl transferase helps cut the bond between the amino acid and the tRNA and attaches it onto the second amino acid. Then the ribosome moves along the mRNA and the empty tRNA is released. You can see it's moving along and the tRNA is released. Okay, third part is termination. So when one of the stop codons arrive in that A site, then translation stops. And then a protein release factor binds at this site and is released from the ribosome. Everything is released. The polypeptide, which is like a string of amino acid, is inactive. Chains of polypeptide can be put together and folded, and then activation of the protein can occur. Hope you like the lesson.